right, so we're going to go ahead and review for exam 4 here. So a positive correlation on your review is either when they agree, like they both go up or they both go down. And if you graphed it, it would look like a positive slope. So maybe the more times I speed, the more speeding tickets I get. That would be a positive correlation. So as one goes up, the other one goes up. Maybe the more I exercise, the higher my heart rate. Maybe this would be the lower my cholesterol, the lower my chances of having a heart attack or some index or something like that. Negative correlation is when they don't agree. So as one goes up, the other one goes down, or as one goes down, the other one goes up. And obviously, if I were to graph this, this would have a negative slope. So for example, the more minutes I spend exercising, maybe the lower my cholesterol numbers will be, something like that. And then no correlation, if you were to graph it, it's going to look random, like there's, kind of nothing there. So maybe like the number of showers I take in a day and how many cars people own or something like. So if you look for correlation there, there's no correlation. All right, let's look at number 2 here. And again, if you didn't try this on your own yet, you're always going to learn more if you attempt something, even if you're wrong, on your own first, and then we'll go there. So look at the number 2, the John's gym problem, and then I will join you shortly. Okay, so in the gym problem, it's just giving you the slope and the y-intercept. So the cost for joining John's gym is, what's your one-time fee? $100 joining fee, one-time fee. And then every single month you spend $40 per month. And you can use Y and X if you want. And then we have Sue's gym. And the cost of joining that gym is a $40 fee and then $50 per month. And again, if you want to do Y equals 40X plus 100, Y equals 50X plus 40, that's fine. If you write these in the other order, like $100 plus 40 per month, that is totally fine. As long as your slope is by your variable, you're okay. So same thing here if you want to write it like that. That doesn't hurt anything. All right, so I want to find the break-even point using algebra. So I want to know when this guy... So when this cost is equal to that cost. And so I'm going to set them equal to each other. So when does John's formula here, equation, equal Sue's equation? And the algebra will tell you what to do, but it should make sense. So again, to remember, do order of op backwards, you need to deal with adding first until adding is all gone, and then you'll deal with multiplying and dividing. Right, and so we got to get rid of all this adding. And so because there's adding in the problem, you're going to use it to get things to move. So I like to keep my variables positive. So I'm going to deal with my variables, and I'm going to put my variables on this side. And I have to move them using adding because we're doing order of up backwards. So to get rid of a positive 40m, you either need to subtract m or add a negative 40, however you want to view that. And those go away, and I get 100 equals 10. M plus, and then that 40 just comes down. All right, so since I picked my variables on that side, that means I want my, let's see, numbers or my constants on this side. And again, see how they're still adding in the problem? So we're still undoing adding, and I want to move my numbers. So to get rid of adding 40, you can either subtract or add a negative 40. But again, you're stuck dealing with that adding and subtracting step until it goes away. So then these go away, and let's see if we can scroll down a little bit. So I get, what, 10m equals, and this is 60. So my goal is accomplished. I have variables on one side and numbers on the other. And so now I'm to the multiply and divide. So we are doing add and subtract on order of op until it's done. So now we're on multiply and divide. So to get rid of multiplying by 10, I am going to go ahead and divide both sides by 10. So m is equal to 6. All right, so because I use m, that kind of helps, because then I'm like, oh, that's 6 months. You might think it's money or something like that, so you got to just kind of remember what your variable stands for. So at 6 months, it doesn't matter which gym I'm going to join. And my break-even point would be 6 months. And if I go ahead and put that back into here, I can check my answer. 40 times 6 is 240. So 40 times 6 is $240 plus the 100. So that would end up being, what, $340 for the output. And then let's check it over here. Sue's gym, 50 times 6 is, what, $300. and then add in the 40, so that would be $340. So that makes sense that that is the break-even point. So either Jim, I could join John's, I could join Sue. If I'm joining for 6 months and then quitting, I'm going to pay the exact same amount of money, which is $340. All right, so I'm going to pause it here. Go ahead and answer C and D and graph it and all that good stuff, and then I'll come back. Okay, I'm going to graph this first before we talk about C. So if we graph it, let's start with John. So at 0, if M is 0, he's at 100. When M is 1, he's at 140, so just a little bit below 150. If M is 2, it's 180, just a little bit before 200. 2 is, let's see where we at, 3, 120, 220, so again, a little bit above. And 4 is what, 160 plus 100, 260. And 5 is going to be a great number to sub in. So if I sub in 5 where M is, that's 200, that's 300. So then I have an exact point. So if I was doing something on my math lab, I would sub 5, 300, or plot that on my math lab, and 0, 100, and then have the tool draw the line. Right, and so John I chose in green, so this is John. All right, and then Sue, I'm going to do the same thing. She's at 40 to start out with. Sub in 1, I would get what, 90, which is a little bit less here. And at 2, I get 140. And 3 would be 150, 190. 4 is going to be what, 200, 240. 5, we get 250, 290. And 6, I get, what, 6, 340. 7 is 390. Kind of off here a little bit, but. And then let's see, 7 is what, 353, that's 390, what I have for 6. 6 was 340, yeah. Okay, I already did 7, and then let's see, 8 would be what, 400, 440. Okay, so kind of up here. So with her, kind of see where it crosses. Okay, so this is the, and we found the break-even point by graphing too, which is, or by doing algebra, which helps. Okay, so 6 months, 340 is the break-even. All right, so let's go back to question C. What does a break-even point mean? Okay, so if you look down here at the red, which is Sue, she is going to be cheaper, because this is less money, it's below, if you join what, 6 months or less. So 6 months is your break-even point. So if you're going to do less than 6 months, you should go with Sue's gym. Now, even though it's more per month, the rate is higher, it has a low starting rate, and so that's why it's a better deal. It's better to pay more per month and then just have that one-time fee be lower, up to 6 months. Now, if you're going to go more than 6 months, then this high starting fee isn't going to matter anymore. So after 6 months, John's is actually going to be the cheaper one, because you're going to benefit from that low monthly fee. So you've kind of had enough months to pay off the high fee, and now you're just going to benefit from the low monthly fee at that point. Okay, so the break-even point is where it doesn't matter, and then on one side of it, it's cheaper to do one. On the other, it's cheaper to do the opposite, and it's because of these Y-intercepts. So one has a high Y-intercept, which is a high starting amount. The other one has a low starting amount. So you can always plug in numbers if you're not sure after what way to interpret the break-even point. But I think the graph is the easiest to see, because this obviously is cheaper here and more expensive over there. All right, if you haven't tried number 3 and 4 yet, why don't you go ahead and do those, and then we'll talk about those. Okay, so let's look at scientific notation here. And again, you don't want to memorize. You want to think about what this means. Negative exponents really mean to reciprocate. So what they really mean is that you have 10 to the third down here. So in a sense, negative exponents mean I'm dividing by 10. So I'm really taking this divided by 10 3 times. And that's what negative exponents mean. So if you divide by 10, you're going to move the decimals. So I'm going to move it. It's right here. I'm going to move it 1 jump smaller, 2 jump smaller, 3 jump smaller. So I'm just going to rewrite my answer nicely. All right, so there's my final answer. And again, remember, negative exponents mean you have tiny numbers that are less than 1. They are small. So if this got bigger, that would be really strange. Okay, this one has a positive exponent, which just means exactly what it says. This says take 3.004 times 10 times 10 times 10 4 times. So when you multiply by 10, it's not a negative exponent. This is 10 to the 4th power. You move the exponent, move the decimal bigger. So I'm going to move that decimal 4 jumps. 1 jump, 2 jumps, 3 jumps, 4 jumps. So I need to add a 0. So 30, what is it? 30,000, 40. And I mean, it makes sense the number got bigger. I'm multiplying by 10 over and over again. And then the other thing is positive exponents mean you have numbers that are bigger than 1. So this has to get bigger. It can't get smaller. All right, go ahead and write your equations for 4, and I will pick up there. All right, so our number 4, we're talking about milk here, and we're just talking about what would be exponential and what would be linear. So in one case, in both cases, the milk starts out at $3. So the first one, it's $3, but we're adding a certain amount every time. The other one is $3, but we're doing a certain percent. So remember, linear is y equals mx plus b, where exponential is y equals, and then you always have a starting amount, you have a multiplier, and you have an exponent. So remember, like arithmetic versus geometric. So they always have this format. So the first one is going up by 25 cents per year. So I can put 25x, okay? And if you wanted to write it like the cost of milk is what, $3 plus 25 cents per year or something like that, you can do that. Just let us know that y is how many years and c is your total cost. And again, if you want to write the cost is $3 plus 25 cents per every year, that's okay too. The other one, it has a starting amount also of $3, but the difference is this is going up by 3%. So you take 100%, you would add 3%, which is 103% in decimal form, and then you would have your exponent up there. And again, if you wanted to use the same kind of like cost thing, you could say cost equals the $3 multiplier, and then you could put, you know, y for year up there as your exponent. Now, if you want to use these formulas, then, you know, you'd have different things. Like if I wanted to know the price of milk, say, in 30 years from now, that's your input. So then you would take 30 years, and here you just take 25 cents times 30, add the $3 to get the price, where here the exponent is your 30. So here you'd have to take 3 times 1.03 raised to the 30 power to get the price of the milk in the future. All right, go ahead and do number 5, A through F. Okay, so first of all, it's super helpful to fill out this chart. So if I look, this is going up by 3, this is going up by 1, and this is going up by 3 as this goes up by 1. So if I go backwards by 1, this is going to go down by 3, go backwards 1, this is going to go down by 3, go backwards 1, this is going to go down by 3, and go backwards 1, this should go down by 3. Okay, and so now I have a bunch of data. So it says, what is a slope and what does it mean? Okay, so my slope is my rise over run. So it's going up by 3 all the time with a rise of 1. So my slope is 3 over 1. Now, what does it mean? Well, my rise has what unit? Grams. So my 3, it's going up 3 grams. And what's this? This is the number of pennies. So this is per 1 penny. So what it means basically is that every penny weighs a gram. So for every penny I add, I get 3 grams of weight. So basically the slope is telling me every single penny weighs a gram. Okay, what is a y-intercept? Well, that is your starting amount. So that's this guy right there. So my y-intercept is either 0, 1, or sometimes we just say 1. Okay, and then what does that mean in real life? So it says, if you look on your sheet, it says weight in grams including the tray. So if I have 0 pennies, it's still saying weighing 1 gram. Well, what is that gram? That's my starting weight. And so that must be the weight of the tray. So the tray basically has to weigh 1 gram. And then I keep putting pennies on it from there. All right, go ahead and try to finish the rest here. I'm going to stop the video here because of time, and then I will start the next video.